Today's tutorial is about how to make a spatial drawing of a more complex structure as, for instance, strychnine, a famous alkaloid. In this alkaloid we have a central cyclohexane moiety. Therefore, we will start with a cyclohexane in the typical chair conformation. These lines are drawn more bold to symbolize that they are in front. And now we can already add axial substituents. And here we should interrupt the CC bond, which is behind, to symbolize that this axial substituent is in front. And this should be this hydrogen here. So, two positions further on, 1, 2, is that nitrogen. Let us add the nitrogen here. 2 positions further is that carbon. And this carbon is connected with the nitrogen via a methylene bridge. Let us add this. Okay. Next, we should draw this pyrrolidine moiety. Close the pyrrolidine moiety, starting here at this position. So then we can draw that benzene ring. The benzene ring should be in axial position down here. This nitrogen is in equatorial position, since that hydrogen is the one which is in the axial position, and the equatorial bond we should draw parallel to this CC bond, like this. So here is the nitrogen which is connected to the ortho position. Next, we will add or close this 6-membered ring with that carbonyl group. Okay, carbonyl group here. This carbon substituent is also sitting at the cyclohexane moiety and should be also in an equatorial position, drawn parallel to this CC bond. And now we have the 6-membered ring. Control it. 1, 2, 3, 4, 5, 6. Next, we should add this oxygen. Then at this position we have that double bond, and again a methylene bridge to that double bond. I think that's it. Let us count 7-membered ring. 1, 2, 3, 4, 5, 6, 7. Yes, this is correct. It should be sufficient. Well, I hope you succeed when you try it by yourself. Thanks for listening.